Hi guys, so I get the special honour of talking to you about refraction, and I quite enjoy this. I can't really tell you why, probably because it's science and science is awesome, but I'm not sure why I enjoy this any more than the other stuff we've covered, but I do. So refraction. Now, first of all, just a tip to basically make sure you don't get your words mixed up when you are doing a test paper or doing your work and get reflection and refraction mixed up, because they're not the same thing. So first of all, let's start with the word refraction. This time, instead of a whiteboard, I actually have some sort of a ruler, I suppose, isn't it? Refraction. So, first of all, what is refraction? Well, it's going to be a little bit harder to show you this because, as per one of the previous videos, I don't have any equipment that normally we would have if we were at school to actually show you this. I will try at some point to, I was going to say I'll find something in the house to show you refraction with a light ray, but then I've got nothing to produce a light ray with, but I can still show you refraction in other ways. For example, in fact, I wonder if this will work. Give me 1 second. Difficult, I can't find a single, here we go, measuring jug. Let me just check if this actually works before I embarrass myself. Somewhat, actually. So if I actually just move this along, you've probably witnessed this before. I'm going to need to change the angle of this to actually show you. Now if I put my pen in there, let's see if I can, 1 second, I'm showing you all sorts of random things on the cake stuff that I'm making later, very exciting. There's no flour in the shops whatsoever, so yeah. Now, can you see? I can't even see. Yes, you can. On the video. Now, can you see how it looks kind of like the pen is bent? Can you see where, if I use this ruler, can you see just here where it enters? Yeah, once it's crossed the boundary of the water, it actually looks like it starts there. When you can see above the water, it starts there. That's an example of refraction in action. I'm a poet and didn't know it. So you can try that at home very easily. And that's why actually, if you were fishing, let's say with a spear, and you saw the fish just underneath the water and you threw the spear where you thought the fish was, it won't hit the fish. You need to make adjustments for refraction, because where the fish appears to be is not actually where it actually is. So anyway, there's an example of refraction. One of my favourite ever demonstrations is the disappearing beaker demonstration. I can't show you that, unfortunately, although I do have a technician friend that might be able to help me try and do one of those, and if we can manage to do that, then I will make another video of that. But in the meantime, you can always look that up on YouTube. So it's called Disappearing Beaker Demonstration. So yeah, definitely one of my favourites. So coming back to what it actually is. So what's happening in refraction is that when light enters an object, or not necessarily an object, a material of some sort that has a different density to the material it was in the first place, then the light will either speed up or slow down, and as a result, it will actually change its direction, which is why when you just looked at the pen in the measuring jug, it looked like it was in a different place, like in the water, than it actually was. So now, if the common examples you will tend to come across is light going from air into glass or perspex, or light going from air into water, or it coming out of water and entering back into the air, or coming out of glass or perspex and coming back into the air again. So those are kind of the scenarios that you would come across most often. So I'm going to draw you a glass block, and again, if we were at school, I would actually have one that I could show you, but unfortunately not. So I'm just going to use these matches to draw, because it's about the right size. Oh, a glass. I don't know if it's actually worked. It's not going to be perfect, but it's going to be, good enough. So this is my glass block. So I'm just going to write here, glass, and obviously out here is going to be air. So I'm going to draw an incoming ray of light. It's going to come in at that angle. You'll notice that I always draw my rays of light at that approximate angle. No real reason for me doing that. I could do it from, the other way like this, but I just don't. Maybe it's because I'm right-handed, I don't know. So there's my incoming ray of light. Noticing again, even though I've been going on about this all the time, that it's a straight line, which is why I've done it with a ruler, and I've shown the direction. And previously I've said to you that light doesn't bend. Well, no, I haven't said that actually. I said light travels in a straight line, which makes it sound like it won't bend, but it does bend. Just not in the way that you might assume. So now, what do we always do when we have light ray hitting an object? We need to draw our normal line. So here is my normal line. Remember, it has to be where the ray of light hits the surface. There we go. Normal, because it's 90 degrees to the surface. Now, from air is going to be less dense than glass. So when the light enters the glass, it's actually going to slow down. And as a result, what it does is it bends towards the normal. So now, obviously there would be particular angles you would need to draw it at, but in year 7, you definitely don't need to know the angles. So just as long as, if it wasn't going to be affected, it would continue on, do you see, in the same direction it was before. But when I say bend towards the normal, this is what I mean. It's going to, do you see that I'm reducing that angle between the normal and my refracted ray? So there we go. Can you see that's not carried on in the same direction? It's bent towards normal because it's slowed down. Remember, this is my angle of incidence. The light is still going in that approximate direction. This is my angle of refraction. Now, I used the letter R before for the angle of reflection, so I don't want to put R here, but that is my angle of refraction, not reflection. Okay, so that's what happens when it goes from an area or a region that is less dense into an area that's more dense, or a material that's more dense. Now what's going to happen when the light hits this boundary here of the glass block? Well, it's going to come back out into the air again. So now this is a case of going from an area that's more dense to an area that is less dense. So again, draw our second normal. Here we go. I'm hoping by now you kind of understand how I'm drawing this normal. I'm not just drawing a random line. Look, 90 degrees. If you've got a protractor, use that because it's going to be more accurate than my guessing. So what do you think is going to happen here? Just have a think first of all. So when it went from less dense to more dense, it slowed down and therefore bent towards the normal. Now it's going from more dense to less dense, so it's going to speed back up again, therefore it's going to bend back away from the normal. So it's not going to continue on like this, it's not going to bend towards the normal even more, it's going to get further away from the normal. There we go. Now I hope that kind of makes some sense. Now I could put glass, this could be water, the same thing would apply, although it's quite hard to have a block of water, unless we're talking about ice, of course. But we're talking about water in the liquid state. So yeah, so what have I covered so far? I've said what refraction is. It's light, it's basically light bending due to it speeding up or slowing down, because it's going from an area that is, you know, of one density to an area of a different density. What is the angle of refraction? Remember, it's refracting here. Yes, the light has bent, but it's still traveling in a straight line. Okay, so you never say it curves. You can say it bends, okay, but it doesn't curve. And it wouldn't do this on its own. If this was just all air, again, it wouldn't just kind of refract for no reason. It has to change, you know, the medium it's going into has to change its density for that to happen. Blah, blah, blah. Right. Maybe I should just say here, less dense here, more dense here. You might need to watch this video a couple of times because, I mean, just looking at that diagram, it's quite a lot of information to take in. You might need to just go through it step by step more than once for it to really sink in. And of course, you can ask me any questions that you want to. You can either comment on the video or you can send it to my school email, that's fine. So, done that. Air into water is pretty much, this could be air, sorry, that is going to be air, this could be glass or water, this would be air back here again. Okay, it doesn't matter. And what direction will it bend if it enters along the normal? So this is an interesting question. So if I draw another block, let's just move this along slightly. Oh, I'm going to mess it up a little bit. Okay, let's just pretend that's a bit of a better block. Now, what I mean is, if I'm going to have my light ray come in at the same angle as the normal, therefore you wouldn't be able to see me draw the normal because it would be along the same line as the ray of light. Then remember, if my normal is at 90 degrees to the surface, then my ray of light has to be at 90 degrees to the surface. So let's say this is my ray of light here. So again, if I was shining a torch, then I would be shining it from this direction here. Whereas, like I said before, on these ones here, I always seem to draw at that angle. Okay, so now if I was going to draw a normal, it would have to be, remember where the light is hitting the surface. So here, I know it's going to cross this point here, and at 90 degrees to the surface, oh look, that is 90 degrees. So can you see that? I could, if you really want me to physically do a normal, then there we go. But it's quite hard to see, okay? Now, what's going to happen then? So if this again is air out here, and this is glass or water, let's just go with glass for now, then how am I going to, remember my normal is going to continue on, sorry. So you can see the normal there. Is my ray of light going to bend towards the normal or away from the normal? And if it bends away from the normal, then which direction is it going to go? Is it going to go this way of the normal, this way? Well, the answer is that it continues along its direct path along the normal. So this is the only case where actually it would not bend, i.e. it would not refract. Okay, it would continue straight through, and the same thing would happen when it comes back out again. There we go. So it doesn't matter if this is glass or if this is air. It doesn't even matter, you know, if it's the other way around. It's going from, you know, glass or air back in. Sorry, I meant glass or water. It doesn't matter if it's going from glass or water back into air. Either way, it's going to go. If it was going along the normal in the first place, it's going to continue in that exact direction. It's not going to refract. It's not going to bend. Okay, so I hope that was helpful. I hope you enjoyed the pen in the water in the measuring jug. You can try that one at home. Just be careful what you put in water. Oh my goodness, I'm knocking everything over. So yeah, just a reminder, anything that you attempt at home, or if I tell you to do anything with water at home, never use electrical items with it. Okay, so if I wanted to put something in water, a pen would be fine, as long as, you know, if it's not your pen, that you've got permission to do that. Don't put anything in water that's going to be damaged, and definitely don't put anything in water that's dangerous, like any kind of electrical equipment. Do not do that. Thank you very much.